Thank you, everyone, for joining today's, 4-day workshop, for 4 2-hour sessions, knowing then, this is going to not be a, highly technical, basic workshop. What I really want to make sure that you understand here is to, get used to Pumas, understand Pumas, and the capabilities that we're able, to really kind of perform. And for you to be able to walk away here knowing, as in all coding languages that we'll have to learn, whether you were an R person, whether you've had to learn non-mem, to know how to read the language almost first, and knowing the proper workflow is, really one of the first important parts to learning any new language and learning any new platform. So really, I've just provided everyone who registered an email with a code block, and we'll go through there once we start talking about and go into the actual Pumas platform, getting everybody in there, making sure that everyone is able to run the code and everything is functioning properly there. But, don't fret if you don't necessarily understand all of the code itself in Julia. This is going to be a starting process, and it's more, I want you to be able to focus more and understand here, focus on the workflow, focus on understanding why it is that we need to do something, so that, when we also direct you to, a lot of the great educational tutorial pages that, kind of pre-exist, within Pumas, which, I'll show you where these are, as well as, throughout the workshop, you're going to be able to understand, some of the terminology, some of the nomenclature, and start to build that foundation so that you're not just, performing, a contextual understanding of things, but then you're starting to learn and grasp the code to go along with it as well. So if that is kind of, out of the way, let me jump in and let's first just introduce you into the Pumas environment. So everyone, hopefully at this point, should have received and installed the Pumas desktop, version of their files, and should have also received a Pumas CP version as well. For me, I am a Windows user, so you will have to forgive any minor changes in kind of talking about Control Shift or function keys, and the exact translation over into Macs. I may you're going to know better than I for these sorts of things, and with VJ on, he might be able to help us later on too, as I believe he uses a Mac. Or if any of you are happen to be together on the Pitt campus and are watching this together, feel free to talk with your friends. But the first thing I want to do is make sure, did everyone, or has everyone received the email? And just to see whether one person says yes. Okay, so then our registrants. Thank you, Jordan. So let me also start my screen share, because this will make more sense. All right. And so you can actually focus on things. I'm going to turn my camera off so then you can focus solely into here. So when you start our Pumas desktop, this should be something similar to what you see. We're in Salk. Oh, excellent. Yeah, everybody have a Pumas party. It's always fun to learn all this stuff together. And of course, too, if there are any questions, we should have some live moderation going on as well, within that Discord channel. If you haven't signed up today, that's fine. Find the email and join, ask questions, provide feedback to us, during the process as well. We will actively try to use this workshop time to really match what you need to know or what you would like to know. So, please be vocal. And I know that is a little bit more difficult in this kind of webinar style setup. We cannot talk back and forth. So please too, also, in the chat, if I'm going too fast or if something also doesn't make, sense, please put something in the chat. I am watching the chat, for those sorts of, more urgent, outlines. So again, we'll keep rolling here. So this should, again, look like your Pumas desktop and something along the lines of when you first start up. You may not see all these different items along the side. These are my particular folders. However, the main purpose here, and I'll blow it up just so that everybody can see this a little bit easier. Over here on the left-hand side is our File Explorer. So you can think of this as, your Windows, typical File Explorer, the way that we navigate and organize our files while working within Pumas. Initially, there will be an initial box where you will be asked to connect a folder. You can also, I probably did that a little bit too fast. If you ever, need to actually execute a command, a lot of the functions that we're going to look into are under this, gear, this settings for manage, and under the command palette. There's a lot of stuff in here, a lot of cool stuff. You will not have to learn very much of this. Really, only two things start. The first, just because you are on the desktop version of Pumas, you need to start the Julia interface when starting it up. It is only bringing up, the VS Code space, which is more of a interactive, system. So we do need to start REPL or start the REPL. And if anytime you need to, up here, I've run these so many times. And once you run it the first time, it should also snap to the top. But if you also start typing things in, it starts finding it. So if you remember the word start REPL, just type in start and it will start weeding down all of the different options for you, where then you can just click it. And over off on the side down here, this bottom section, if we think of it as kind of three parts, our File Explorer, our terminal space. If you're, I'll use some kind of common terminology, maybe for those of you who are more familiar with the R environment as well. This is our terminal space where you have, the PowerShell, so your typical, actually, more C prompt, and then an actual Julia window. And once you see this Julia icon show up, Julia is loaded and ready to go. The other thing we'll make sure to set up here is open folder. And again, sorry, everyone, this is a Windows system, but you can choose, a similar common sort of place where you want all of your files to be stored and to be able to draw from for the purposes within Pumas. Again, if you're used to the R environment, you can think about this. I believe R will still typically try to install, or RStudio will still commonly take you within the documents section within Windows systems. It's nice, easy. The file path is relatively short too, so you also won't have to worry about that as much. I personally created another folder within there just called Pumas desktop files. Just so then I can, easily organize, all these other things. And, as you can see, you won't have to mix and mingle with my other R folders, kind of contained within my new folder. So you can select that, select folder, and then it will populate your File Explorer over on the side. Now that then gives you the option, a couple different ways then to actually get your files into there. So one is you can always open up your individual, File Explorer tab, drag and drop the individual files from the zip file that were provided. Now, one of the other things I do want to point out to you, and just, for ease of use, drag and drop is a full functionality, within this. And for those of you who eventually, may use this in industry or use, more of the web-based type platform where then you're going off of Julia Hub. That's going to be one of the many ways that you could always upload files in, and that's through a simple drag and drop interface. But that will, if you unzip that file folder and drop that in there, this should provide you our full set of working code that I'll be using today to kind of walk through your initial introduction to Pumas and kind of the workflows that we're going to utilize here. And while I send it to you later, I will make sure here, if you want to write down for later, and I'll try to leave this up for a minute just so everybody can write it down. We will have an open GitHub repository of all the code that we do work on, for later today. If we add on some extra code, or if there are any other extra questions that we could throw, some specific examples of working, files. This will be our GitHub repository that everybody will be able to go and essentially re-download and obtain, fresh copies of the code files that we'll be using for the purposes of this workshop today. So let me just leave that here and give you a few minutes. And once everyone has had a chance to get their files placed, just give us a thumbs up, give us a I'm ready to go into the chat. I say Jordan's really interactive today. Thank you, Jordan. Thank you, Christine. I got to admit, you guys are lucky that this isn't a two-way audio, because I am definitely one who will start calling on people as we start walking through items. And maybe let me also rephrase this. Is anybody having particular issues with getting the files or the files into their Pumas desktop? Okay, I'll take the silence, or the, well, I shouldn't say silence, but the lack of notes here, that everybody is working, and or that this is working and it's functioning semi-well. If you excuse, just to be able to zoom this out a little bit, just for feasibility. The first thing I want to walk you through, today, well, let me go over what today's sessions are, going to include. So, in our 2-hour chunks, we'll have some kind of continuation, between the days. Today I want to make sure to get you page not found there. So the link right now will not function. The GitHub repo is marked as private, and I don't have the access to make it public. So that's where the link will function afterwards. And that's where, the files were sent out in your email. So please check your email that you provided with the registration for the webinar. And that is, essentially the same code folder that you're using, that we have for right now, that will be found on that website. So what I really want to make sure to cover today is, we're talking you through the initial Pumas desktop environment, just how to initially navigate through these sides. We'll also do a little bit of just a check to make sure everything is functioning properly and that you're able to generate some of your outputs, and just being able to use the interface itself, getting to learn some of your key keystrokes that you're just going to need to grill into the back of your brain. Again, this is not a very hard thing to do, even less so if you've done something like within the R environment. Next, we'll start knowing that a lot of our presentees here are PharmD students or have a PharmD background. I want to be able to present something that's somewhat a little bit applicable and something everybody is going to really use outright, and that's an initial non-compartmental analysis We'll actually run it initially within the code form. And then I'll tell you a little bit about Pumas CP, so you have a chance to be able to see, and we'll talk about the differences there, but understanding the workflow for non-compartmental analysis, its applications, and kind of the ease of use for everyone here as a user. For the second kind of half of this, I'll translate this over or hand this over to BJ, who happens to also be the CEO of PumasAI, in case you didn't happen to read his bibliography. And he'll walk you through the initial concepts of kind of pharmacometrics and modeling, where then we'll continue that into the next day, where we'll actually dig into more of a foundations of the pharmacometrics in a model build sort of workflow. We'll continue that, move into the second day and into the third day with PK model fitting, diagnostic plots, VPCs, before ultimately moving into simulations. These simulations will include things for visual predictive checks and large batch group sort of simulations that may need to be performed just while you're checking your PK or PD sort of models that you may end up developing or maybe reviewing as part of your future career path, as well as performing actual simulations. And then we'll also touch on quickly at the end reporting and some of the extra functionalities, because I got to admit, everybody hates making PowerPoints. Can delink the one of the chat members. Oh, yes. That's actually a very good idea. Thank you, Aditi. Let me just drop. There we go. The chat in there. So now everybody should have a running copy of that link as well. Yes. So that's kind of the gist of what we're going to start working on. What I will walk you through now. And so, sorry with everybody. So the link above will not function again. I'm just making sure of that, unless it got activated in the time that I've been talking. If you are still missing the code file, please send the note on the Discord channel, and somebody offline will get you in with your email or with a valid email, and they will email you the code file so that you can continue on with us kind of in step. So I'll continue kind of here, and I want to kind of walk you through this first checks folder. And so I want to make sure that everyone is able to generate a proper output, just knowing that, Julia is kind of working. If you didn't have a chance to actually run the Pumas qualification, yourself, but using this also just as a quick and easy way of, letting you understand some of the, keystrokes and, how we kind of organize our files in a typical fashion. So a Julia file or Julia language file ends in .jl. So this is going to be one of the typical files that we're going to use, within the Pumas space. You will also see we'll use Quattro Markdown files or QMDs. This is a kind of unique aspect and kind of a reporting aspect. And I'm going to first walk you through a Julia file, which is, the base language that we're using and everything. And, the NCA will actually use a QMD file for the purposes, kind of also as to show you kind of some of the extra reporting templates that are going to be able to be used for these sorts of outputs. But if you ever need to create your own file, it's just as simple as you would for any typical sort of, new file setup. You just right click, create a new file, and you give it a test.jl. You can name it whatever you like. You can even actually create, even if you had an R environment or a QMD, we can do the same thing as test.qmd. When you create the file, it's reading what that file extension is. to be able to understand, what it's going to actually end up using the file for, how it should be formatted. So if we open just and click on checkruns.jl, this is going to be kind of a very simplistic sort of setup for a initial PK model build. And just let me try to maximize the amount of space that we're going to be able to see here. So one of the first things that we're going to want to activate is the libraries and the code packages within our data set. If you're used to R, you may be used to be able to see the libraries, and then something like StatsBase or Table 1. The equivalent of that here in Pumas is using. To be able to run individual lines, you are either going to Control Enter or Shift Enter on each of these lines. The only difference is if you use Control Enter, it runs the individual line. If you use Shift Enter, as you can see, it'll run the line and then jump down to the next available set. So just depending on whether you want to do initial small sets, or whether jumping and rapidly progressing through several sets of lines within the file. Similarly, you'll be able to highlight multiple lines all at once, and either Control or Shift click all the same again, and it's going to be Shift Enter to be able to run these codes as well. In the cases for items where it's a package setup, you get these little check marks, giving you a little bit of a note just to tell you what it is. For other items, such as now, if we want to read in a data set, it will provide you with a very brief description of that particular data frame, and hovering over these individual tabs actually provides you a lot of extra information to be able to scroll through and just to be able to initially preview the data that you have. The other spot where that will be is, of course, down in your REPL. Thinking this is your kind of code, almost terminal space. Now I can understand, it marks it off. It's jumping. We're about 1,900 lines. We're only seeing really 7 of them. To be able to see a full data set, and again, linking back to knowing that some of you are going to be in more of an R mentality, where you have this little index box on the side, where then you're going to have all your data sets and data frames set up. There are 2 ways that you can pop that up. The first is, the VS coded display. So VS Code display, and then your particular data frame, you can run that and it pops up a separate window, where then, whether you're able to drag all around, view all of your data as you typically would. You can sort your data. So all of our IDs, whether top, down, again, putting it back to normal, or being able to sort it and categorize, items based off of, your most common kind, typical sorting algorithms. So, a very, common thing, I want to be able to check the dosing rows, within our data set. So those would be typically coded in our, data sets as an event ID, EVID of 1. So I'll filter this for an EVID of 1. And so then I can just see here, IDs 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're checking our dose group, checking the compartment, things that you may want to double check as you're setting up your data sets moving forward. Now, that's not necessarily especially as you start working through a lot of different data frames, your data wrangling, modifying your data. You're going to start making PK data, missing observations removed, all these sorts of different things to be able to get yourself into a final working data set. This is from a package called PharmaDataset, so it's kind of already cleaned up for you and doesn't have data wrangling components to it. We will go through some of that within our population PK workflow over the next day or two as part of that. But what I want to point out is, if you ever lose track, you type into the REPL whatever it is, and you can get your snapshot down in the REPL. Of course, if you expand your REPL, also, if you notice, I didn't type it out. If you click in the REPL and just hit the up arrow, it'll give you your most or your last run, or you can filter through the various different commands that you may have just run and hit enter, and it shows more. So again, feel free, play with the size of your REPL. If you have a 4K monitor, it's even better because you can just fit more on your screen at once, which I am definitely guilty of, investing in a larger monitor just to make sure that I can see more all at once. But what I want to be able to also show you is, where are all these things stored so that you can also pull them up and inspect them later. So the equivalent of, again, what you're kind of looking for in R is this Julia tab at the bottom. So when we open this up, you may actually see it, and you'll have 3 different sections: your workspace, documentation, and plot navigator. Documentation, you can pretty much minimize because you're not going to have much going on in there that you'll need to have to deal with on a regular basis. The plot navigator, just to let you know, anytime you generate an image, where you'll see some, we'll walk through here in a little bit, it'll pop up off to the side. Each of those individual plots, numerically will show up here. And so if you ever, don't want to just click back and forth, left and right, you can select the individual plots here just to be able to kind of jump through and see what you've done. Gets really helpful when you're on, version 46 of a plot, and, you're trying to, maybe make something towards a particular template that your company may be using, or everybody has, that one PI maybe who just has, a particular focus, and they want their plot their way because that's how they're used to seeing it. This allows you to be able to kind of play around and just see all your prior iterations. Really where you'll want to focus a lot of this is within your workspace tab, and you'll come to learn just all of the different little images, what they mean. A lot of this right now is background packages that are loaded already within the Pumas environment. And what you're going to want to look out for, really for there, are these little blue boxes that mark, that it's a data frame. And ultimately what you'll want to do is, off to the right side, there is this extra kind of, looks like a little kind of stylized box. Tells you to open in VS Code space, which sounds very similar to, the actual command. And so if we click that, we're able to pop it up. So if we have a PK data, PD data, NCA summary data frame, all of these will pop back over, later on once we start running our NCA summary here, and just to be able to let you see kind of the difference, once we've done a bunch of things, and just kind of to be able to pull out these individual items off on the side. So that is our kind of initial check. The other thing I just want to make sure you guys are able to run, these are set up in terms of how most coders kind of have a standard form in terms of individual lines. I will fully admit I was one of those people who everything was on an individual single line just for ease. Eventually, for certain items, you'll grow to learn and love this sort of setup. It is a little bit of a learning curve sometimes, though, especially if what you're used to and how to read code. And everybody reads code in different ways, so it's just important to kind of start to learn, understand how you like to learn things. And again, we try to translate and accommodate as much as possible. But if something becomes confusing, let us know. Throw it in the Discord chat here, and we'll try to go back and make sure to cover this. But versus something that is just a single line, anything contained within your parentheses, as long as you're at the end of that parentheses, it's going to run everything contained between that. Now, this is important when you start getting into a data wrangling setup where we may be modifying, mutating, filtering out, creating subsets of data. Instead of making sure that you ran each individual line or that you're blocking, all 50 lines to say, to set up your, data set. We'll actually show you how, there are these kind of chain blocks, and you create, these sections so that you can make your life really quite simple while running your code. Similar idea of this model block, which right now don't fully expect you to understand, the full intricacies and setup of, this is what is going to set up for a PK model block. You don't need to run each of these individual items. You can see how the model is comprised fully going down from 1 to 77. And really, as long as I am not selecting something, so, I selected the ND and end on here. So if I hit Control Enter, we get an error because it's trying to run just what you selected. But just having your cursor anywhere within this block, you run it, it understands you're in the middle of a large chunk, and it's going to run that whole chunk. And again, whether Control Enter, Shift Enter, all just depends whether it's going to move down, forward, or not. So hopefully everybody has been able to run these so far and able to generate, similar sort of outputs. Again, everybody tried to do, Control Shift just to be able to see also, each of these. And I do want everybody to try to run up to lines 83 just to be able to see and make sure And so you should be able to see something similar to this at, whoops, streaming connection recovered. Did I drop out for anybody? Whoops, uh-oh. Thank you, okay. So hopefully what I really want to make sure everybody to do, and if you haven't done anything to now, just drag and select everything up to line 83 in the code and Control Enter, or I'm pretty sure there's a control button on Macs. And I've never had a Mac. You'll have to forgive me. I'm sorry, guys. But run that. I just want to be able to make sure, if you're able to get this fit and you end up with this output, that makes sure that at least your Pumas was installed correctly, and that you're at least going to be, as we're walking through the code, it's going to function today. And so we're not going to have any particular software sort of sides and hiccups. So once you've had a chance to run that, it may, depending on your individual system, again being the desktop model, it should still run quite quickly. Just give me a thumbs up in the chat. Zod, good, you ran, and that means you also got the code then. And I'm just going to butcher the name. I'm sorry here, so I'm not going to try. I always feel terrible about that, and that's where I wish we had some two-way talk here. Excellent. Did anybody run into problems, or did an error occur for anybody? Nope. All right, that's good. Super. So that gives you, kind of the general aspects of just the Pumas environment. And as you can see, really just get started with the Pumas environment. It's not all, that complicated and not all that different, from other things that you may already be using to perform, regular kind of clinical pharmacology, or other pharmacometric sort of tasks. And again, in terms of what we're going to be using, really within our Pumas interface, think of the Julia tab, the 3 buttons. You could almost think of it stacking, all the different things that are there. That's what's in the background. And so now you can actually see this is actually a good idea. it shows, we have our PK data frame, we have a model object, we have a fitted Pumas model, gives you all those different names. So especially as you start building these up, and you may forget what you may have labeled things. I got to admit, I've also been one of those of let's just FOCE1, FOCE2, FOCE3. And we'll talk about units as well, Emily. Especially, and actually there'll be a version of that actually should be coming up within the NCA block as well. But now you'll just be able to see that. Otherwise, you're probably going to be living within the File Explorer, just to be able to have it, open, to be able to know what file you'll be able to work on. I'll try to also touch on while we're going through the PPK workflow. There are several different ways to be able to set up your own workflows, and you'll notice in the real world, in pharma industry versus academic settings, there are tens of hundreds of styles of how people tend to like to organize their file, and everybody thinks that their way is the best way. I will try to show you or hint on some of these ways, and just ways that you may be able to see it, and some of the ups and pros and cons that you could take from it. But ultimately we're trying to show you initially just a simplified workflow, and what needs to be done to be able to initially get your feet wet here within Pumas, so as at least when you're also going through all of the intro materials and the videos that can be found at Pumas Labs, you're not going to be starting from ground level, starting from the base. All right. So the next thing that I want to work on is walking you through initially a non-compartmental analysis sort of workflow. And so an NCA workflow is probably, especially if you go into more of a clinical pharmacology or a ClinPharm lead sort of setup, you may be expected to perform these sorts of calculations and reports for summaries for your clinical trial operations groups, to make sure in an ongoing continual basis as well. For those of you who aren't familiar necessarily with single ascending dose studies, this is really one of the it should be the first in human studies that's going to occur for any investigational new drug after the IND application. And the purpose there is really to make sure that your drug is safe, as well as you're going to start obtaining your initial pharmacokinetic data and characterization on this. So, it's also going to serve as a wealth of data for eventually, if you are building your population PK models. So if two of the things that really that we want to be able to get out of these sorts of analyses are going to be a summary of PK parameters. So most of you at this point, I believe all of you probably have been through at least your second year of the PharmD curriculum. So you probably had a clinical pharmacokinetics sort of course, or for some of those, I think we have somebody joining us from a hospital and unsure of credentials, even medical schools. Typically you end up having a clinical pharmacology or a clinical pharmacokinetics course as well. So understanding and being able to first generate those PK parameters, as well as understanding the dose proportionality of your particular investigational drug, is because some of the main outcomes and outputs that we really need to understand within a SAD study. Now, I did mention we're using this QMD, a Quartro markdown file, for this particular use, and that's where this header is more about and purely useful for certain formats within the rendering of the QMD file, because the final output is actually in HTML. But the purpose of that HTML kind of web form is to be able to provide it so that replaces what you're going to need for a typical report. So you don't need to necessarily set up and copy and paste values from a data frame or an Excel output into a table and then have to format the table. Transcription errors aplenty can occur. And great, in 2 weeks' time where you may have additional data, now you have to update all of this. Did you make sure? Did you actually copy over the most recent image that's occurring? Again, transcription errors can occur. Having these sorts of reporting functions allow you to be able to kind of stop gap and make sure that whatever you are coding, as long as you are going into your code setup in the right frame of mind and planning ahead, try to make this, and think of, what is it that you actually need your report to do? And what is it that you need to present is one of the most important things you can ask yourself when starting out on any sort of analysis. Because we don't run NCA for the purpose of NCA, or we don't build a PK model for the sake of having a model. The purpose of it is to query and ask questions of it. We need to understand, in this case, maybe for an NCA analysis, where is the maximum, dose proportionality, dose linearity occurring? What if, in our PK model, we've only ever explored once daily dosing? Well, what if I did twice daily dosing? Having a model for the sake of a model is never the purpose of, pharmacometrics. It may seem that way just because it is, now such a foundational aspect of so many different, drug packages, NDA packages, but we are using it for a purpose. So never lose sight of that, as you move forward. So the QMDs are also set up a little bit differently in terms of, and if you're used to our markdown documents, it actually would be maybe look a little more similar in terms of we have different little code cells. The easy way to be able to add this is if you hold Shift Control I, it'll pop up your individual, or it'll pop up a new code block. In this case, because of the Pumas desktop, it'll automatically default into a Julia platform or code base. But just know, for these things, if again, real world industry aspects, you could have a mix of things with things like Python or things as well contained within. And that makes this a little bit easier too, in terms of, instead of having to run individual chunks, you can just choose to run the cell and it runs everything in here. So again, this is kind of a setup, and we're calling on all of our packages, loading all of our code libraries. We now can just hit, run cell, and it runs everything within there. Similarly, you can run certain items. The idea here of, individual singular chunk for performing an individual data wrangling operation, or performing an initial fitting, or pulling and performing a particular diagnostic test. If you have it all contained within one chunk, and then the output is going to be able to be displayed into your fancy HTML Quattro reported kind of rendered file, that's going to make it look a lot snazzier and cleaner on the back end. It helps organize your data. And I got to admit, I'm one of those, I heavily like to comment my code lines. And again, for commenting, adding the hashtag out in front of your lines is going to kind of nullify anything that is going to occur on that. So it is giving us a note on what we are doing. You will see, in some of these, especially once we get into the population PK, code sections, there is a lot of coded comments. And I highly encourage you to develop good commenting habits now, because you never know, especially, within the academic or industry arenas, you never know who is going to need to incorporate your model for another purpose, to be able to understand what it is that you have done. Just having a whole bunch of code just laid out can be very daunting, confusing. To be able to, also leave notes to yourself in terms of, Emily, you actually, this is one thing I always like to comment on, within my model blocks, units. Because so many things and most coding programs are not going to necessarily automatically convert units for you. So it's important that you understand whether, this one is being input in nanograms per ml, but the assumption here is I want this in liters. So we need to multiply our milliliters by 1,000 divide by 1,000, not multiply, to be able to get into the right sort of units. So it's good, fact check, and just to be able to help anybody who may be spot checking you and reviewing your data, as well. This also allows you, specifically for this QMD sort of file and setup, it lets you then, outside of your individual code blocks, you can add in extra kind of informational aspects that are going to be based off of, kind of almost like a traditional report. So you can build your own template for your lab. A lot of companies will have their preferred kind of standards of what they would like to do, or layouts in their particular headings. And again, it follows, very much the same style of other coding languages of, our one hashtag here is going to give us the largest header, 2 is going to be the next down, 3, and I believe it goes down to 6, individual different kinds of subheading, sizes. The colors and such that come from each of these will also depend on somewhat of the theme. And actually, let me walk through this and then I'll go back. I forgot to talk about appearances, just because I know everybody likes to, some like dark, some like light. Somebody remind me at the end, just in case I forget it. As well as let me know if this darkish sort of theme does not work well for you and you're not able to view the screen quite as easily, and I'll change it more acutely. But again, point being, sorry, not point being, but having this extra data in while you're laying it out almost as a report is helpful, both for you and understanding, to make sure you understand the data that are going to be going into your own analysis, which is really important. Again, just in terms of the data frames that we're providing in this particular example are kind of pre-cleaned. Unfortunately, in the real world, we do not necessarily always have, the neatest and tiniest of, data sets. And we need to, understand the problems, issues that may exist. We should understand, what is the data that we are, investigating. So in the case for our, theoretical SAD study that we're looking at, our investigational drug is an oral drug being administered at 1, 3, 10, 30, 100, and 300 milligrams. As a single ascending dose study, it's only one dose, single. Kind of makes sense, versus our MAD, multiple ascending dose studies. We're also collecting, a very rich plasma, PK drug concentration profile over, I believe this is, 19, time points. This is where, your SAD, MAD, your first in human studies are some of the most beneficial, data that you're going to be able to have, especially for developing your population PK models. And this is why we do not skimp on the PK in these first in human studies. Sparse PK can be done at later points once we know and can kind of with assurances know that we're able to characterize our drug and that we're able to kind of make remedies, and that sparse sampling will not affect any sort of questions that we may want to ask of our models, and that we're going to be, or even the statistical outputs that we would be expecting. So again, always have, it's not a model for the sake of a model. We need this model to answer a certain question. Make sure that you have data that logically you will be able to get your answer, because in these sorts of patients, you can't go back, it's one and done. We can't, we don't want to have to rerun, a multi-million-dollar study. That would be very, very bad. So that gives us 6 dose levels, 19 time points per each individual subject at each one of these dose levels. And we have our data set already set up with kind of our most common headers. And if you haven't heard of or know of CDISC standards yet, and ADPPK sort of data set standards, which now have really, to my knowledge, they're being enforced at this point. Certain of these headers are standardized across the industry. So NFRLT is does not make sense from the outside perspective, but it's the nominal relative time from the first dose. And so you will eventually learn these different acronyms, and nominal time, NF turns into AF for actual time. AF is AP or NP based off of, instead of nominal time from the first dose, but from the prior dose. So your nominal time for a multiple ascending dose is going to run from time 0 to, say, hour 144. Whereas your ANP RLT, if this was a once daily drug, is primarily going to be constrained between 0 and 24 hours. Would you recommend maintaining a codebook file or is keeping a column legend within the script? So depending on the purpose of your codebook file, and this might be, so really our code for each of these files is meant as a kind of one file. Everything gets done there. It's used to be, if you're used to kind of a non-mem sort of setup and workflow, you have a model file, you have your control file, you would have to be able to take your output from a list file to be able to read it into, let's say R for all your data kind of, plotting. You may use R or another different file to be able to generate for your VPCs, and that file has to be able to go back over to generate the VPC image. Everything is able to be done in a singular platform within Pumas. And so that is, kind of one of the main kind of focal points we want to be able to hark on everybody, is really that Pumas is going to serve as, as long as you're, able to get everything and, learn the coding and setups, you're going to be able to perform all the analyses that you've been able to do, but in a singular file. So in that way, your one file will serve as your code book. So depending on what it is, maybe you're querying your code book file for. Again, thinking more here, a column legend. It's commonly not really held. But you can always, I guess it's never bad to have a common standard, and I guess maybe that type of legend doesn't necessarily fully exist, because the things like NFRLT, NPRLT, EVID, evalu, dossier are the normalized column headers through CDISC standards. So hopefully that maybe explains things a little bit. Though I would recommend, again, it's as long as it's reasonable. And again, within these NCA sort of workflows, you're not dealing with multi-hundreds of columns. However, you will have, I'll make a note in reporting. I'll see whether we can touch on metadata and how in your actual data set, you can add into, say for PK data, we can add labels underneath, such as for ID. If this was a more CDISC compliant data set, it would be unique subject ID sort of thing. We can add the metadata label under it. So that would be, identified as a unique subject identifier in those long words, no more than 40 characters, just because that's, also part of the standards and the limitations for the file type that they have. So that can help you and add. So if you don't remember and you're able to just, have all these labels within your data sets, that might be one way, versus a code book. That would also be something applicable that is needed to be done for e-submission files. So when you submit items to the FDA, there are a certain set of standards. We probably won't have enough time to be able to talk about that in specific. However, leave a note in the Discord channel. I have a feeling that at the end of this, there are going to be some extra questions and, specific comments that people are going to want to talk about or certain areas. And, maybe we can talk about doing some like lunch and learn sort of sessions, little 1 hour, very focused sessions to be able to kind of delve more deeply into a technical aspect versus giving, more of the broad higher end kind of workflow going on. Excuse me. So to jump back into kind of our NCA analysis, the first thing that we're going to need to do, or really our NCA analysis, is composed of 3 steps. That's all you really need to remember. The first is being able to read in your data. The second, we need to create the NCA population. And the third, we actually need to run the NCA analysis. It seems really simple, but if you ingrain those 3 things into your brain, that's going to tell you really what the functions that you need to execute to be able to kind of run your full analysis. So the first step, we need to read in the data. So we can read in CSV files, Excel files, SASBAT files, XPT files, which is again is a SAS transport type file. If you're in industry, the CROs are going to provide you XPT or SASBAT files. And with that, we use ReadStat. The basis for any of these, kind of document, sort of set up in readers, it's going to have, a pathway that will lead you to your file. So, this will differ for your individual, pathway, or for your individual computer. In that data folder, one way that you will be able to find out, at least, if you're not, used to seeing this, if you right click, you can copy the path. And I'll just put it up here. So you can be able to see, and use that as kind of reference as you're going in there. So, for a Windows user, it's implied C:. You're not going to need to include that. I'm not sure how, things like that will look within the Microsoft, or excuse me, not Microsoft, within a Mac sort of setup. But you can provide it as a absolute path like this. So that is, from wherever your primary, kind of computer setup is, it's going to be able to figure out where that folder is, where your data originates. So again, we have this under, this original kind of Pumas desktop files that I created myself. We have our initial intro to Pumas 2025 data, original, and the SAD data set. And then we pipe it into a data frame, versus the ReadStat will just have it as a still as a SAS file, and we'll just let it review and show us the first 5 sort of rows, just so we can be able to see what we're looking at. And again, if we want to be able to see everything on the side, because we are not able to scroll to the side, that's where we go into our Julia tab, and we can find that data frame there, open VS Code, and you see all of the data set. Scroll side by side, and you can inspect your data for your initial input. One thing I do want to just highlight and let you kind of know exists, using absolute data paths is not always going to be the most efficient way for you to be able to kind of connect to your files, because depending on, now you swap over your system, you start moving things around, this absolute path doesn't function. And so we have several different tutorials that use things like your directory or file location to initially be able to tell you how far and where it should actually start looking for things. And this is actually, if I run this one, it's actually going to tell me it's not able to find the file type. But if I actually, or if I copy paste it in, should have actually. The one thing I want to be able to point out is whether you run things within the individual code cells versus at times when you copy and paste it within the actual REPL itself. So if I use this versus copy and paste it in, you can see it's actually a different file setup. So if you're not initially getting the initial file type, or it's not reading correctly, just take a step back, try to do some diagnostics, be able to pull out and make sure your file paths are correct. In this case, if I want to be able to run it from the cell, this extra NCA kind of folder step is still included there. So actually what I would need to do is include a step back to now be able to get it to run similarly. So now these two actually show the same way, but it's basing it not off of an absolute path. It's using the initial directory basis for where your file is, and it's working from there to be able to figure out where you're trying to pull your data from. So again, there are several tutorials on this, but I want you to know, that exists. You kind of need to, when I ran recess, I ran to the error, unable to open file. So that's most likely the pathway is not correct for your particular code. And again, that's going to be, unfortunately, something that's going to be individual for each system with whatever that individual file pathway is going to be. And we can try to see whether we can troubleshoot that here at the end of the workshop to make sure that you're able to get everything to function straightforward. Point being, step one, we get completed. Data set is read in. We're not going to have to do any sort of data wrangling steps just because it is already partially cleaned. Now, a lot of this extra, these next few blocks, I'm not going to expect you to understand the code setup. What I really want you to understand is that you need to understand what it is you're analyzing. And so an exploratory data analysis, or an EDA, is quintessential. After you perform you import your data to be able to see, do we have any samples that are missing? Do we have any samples which were below the limits of quantification? Do we have any subjects where there are no observations and there's only dosing data? That's something, not common necessarily towards a SAD/MAD study, but later on, certainly so. So being able to set up tables, and so some of these are going to be a little bit more kind of informational and some base code for you to be able to see, but it'll let us be able to also look at some of the initial table outputs, kind of that we'll see off on the side, and then how they will eventually get translated into that rendered QMD HTML file. So one of the, a summary of the subjects is going to be, kind of a basic, it's table one in a lot of sort of setups. And, we can ask and set up some basic math just to be able to let us know how many subjects were treated, just by looking at how many unique subject IDs there are within our data set. We can look at the PK database, and again, that's going to be based off of, for this particular summary of, okay, well, now we have how many PK samples and subjects that are unique based off of their subject ID. And generating a percentage of each of those and how many are flagged. We're just saying the flag is 0, just for the purposes of our kind of faux example pseudo study that's occurring. We set up our own data frame and be able to summary. Again, when we get into some of this later on, to be able to understand the setup of a matrix and these summary tables. I think it'll make a little bit more sense once you actually be able to see. Let me shrink off to the side here. So when we actually set up and run our individual subject summary table, this is our kind of setup. It tells us we set our own subject headers. We defined what each of those columns was going to be based off of kind of our own data frame, kind of data wrangling sort of math. And have it as an output. You can preview it now here within Pumas. And again, it gets very nicely presented once we get it into the QMD file, and it'll resize itself regardless of whatever size you may make your window off to the side. Similarly, we can do a similar item for the number of observations. So we can see, just again, to understand what it is we're looking at, we have 60 subjects in our SAD group. We're able to collect PK on 100% of those individuals. We have 1,200 individual PK observations, with one dosing event per each subject. Again, that makes sense for the single ascending dose, sort of group. There are 19 observations per subject. There's 60 missing observations, and we added in a footnote. Of course, this is going to be missing, especially for the initial dosing where, well, there is no drug at that point. So, it kind of makes sense. So good. We know how many subjects, we know we have PK data. We're not missing anything that is kind of unexpected. Again, this aligns with the 60 subjects and their pre-dose sort of setup. And similar in a different way, or kind of a different table setup. Some of you, again, from the R environment, maybe used to table 1. There's just another way we can generate an initial subset of our data, again, focusing on the dose lines, really just as a way to make sure that we only have one line per each subject so that we can make a demographics table. And then using that subset of demographics table, and maybe some of this too, Prina, instead of a code book, or, this is where, you have your specific name. So instead of age or, weight BL, this is, the weight at baseline kilograms, and you can set it up however, the correct name that you may have for your own understanding. But when we run, oops. Something here. Let me, sorry. I run before. Sorry, guys. There we go. Oh, it's because I was only selecting part of it. See, even the best of us, because I was only partially selecting part of it. It wasn't running the full cell. So with table 1, this is a nice package, function to be able to remember for quick summary sample sort of analyses. So we're able to break it down, each of those 5 demographics that we had specified, and sorted based off of the dose as well as total, for your individual study. There are ways that you can summarize this and create more specific if you want geometric mean and geometric CV included. Again, that is covered in some of our other tutorials, and is a little bit more advanced versus kind of just what we're planning on going through here. Finally, one of the other kind of key outputs that we would have for an NCA analysis is a listings table. So we want to be able to have that concentration data or the PK, parameter listing for each of our individual subjects, and that's using this listing table, subset. And if at any point you come into and you don't know what the keyword arguments are that are available for any particular function, in your REPL, if you hit the question mark, so like shift question mark, it shifts into this help setting, where then if you type in things like listing table, it gives you the documentation so that you're able to look up and be able to see, okay, well, what is it that it's looking for? What are the various arguments that you may be able to work in, and how they need to be, formatted to be able to work. This gets, handy when we get into some of our other population, read Pumas or read NCA sort of type outputs, where you may forget, or, what is it that needs to be named? What are the minimal required information to be able to get this to function? And if we just quickly run this just to be able to see this, really what it's going to be able to give us is for each of our dose groups and by individual IDs, it gives us our, individual concentration time data and summary statistics on each of these, whether geometric mean or geometric CV. And I included a function here that's just going to save everybody time because nobody likes calculating the geometric CV percent themselves. Show where the question mark is again. So it's the, if you click down in your REPL, and then it's just like on your keyboard, like if you're typing in a question mark. So it would be, shift / So like type in whatever you need to do to put in a question mark. Got it, there you go. And to get out of it, backspace if you have nothing, or enter, I think also works as well. So we looked at our data frame. We did a quick and dirty kind of exploratory data analysis, but also generated some useful listing tables and summary tables. So now we're actually on to step 2 in our NCA. We're going to try to run through a bunch of this because I'm sorry, BJ, for eating into your time here. Step 2, we need to generate the NCA population. We need to generate the population. We need to read NCA. So let's, just because we were just talking about that, read NCA, and we can look at, the documentation that comes into us. There are, again, documentation can take some, time to be able to read too, but this is also giving you a full set of, kind of the expected, what the inputs can be at their maximum. This does not mean that everything needs to be provided every single time. Emily, to your point, concentration and time and amount units can be added in, through here at this point. And I'll work on a version which has units included here, just so that you also, have that as a option and just be able to see it. Personally, I don't like to include that just because it will include units within the outputs. And it makes certain data wrangling steps afterwards, or the use of those, because now it's not, say you want to plot your sets of clearances. Well, now it's not a column filled with numbers. It's a column filled with numbers and letters. So it recognizes it as a string. It's not a column saying, 2, 2.5, 2.2. It's 2.1 liters, 2.2 liters. It's not going to recognize that as a number. So, it kind of hampers some of your functions going forward. So you can do it. I would recommend actually running that as a second population, so that you can generate kind of 2 separate data frames, one then maybe that you can carry forward, for other plotting functions, the other one being useful more for kind of outputs and ease of use and friendliness. But the minimum data that we really are going to need is presented here. And even with this, amount does not necessarily have to be included, so long as you do not need dose-dependent materials. The bare minimum of what you're going to need is to be able to provide is the ID, the time, and where the observations are going to be. So our unique subject IDs, we're using this, CDIS standard NFRLT nominal time for the first dose for our time, and the analytical value for our observations. And listed route, the route in this case, is an extravascular, which in this case is really oral. And I believe the only routes that are going to be viable are EV, IV, and there's one more, and I'm blanking. I'm sorry. VJ, if you're in the chat, sorry. I just cannot remember. That's going to bug me. But one thing also too is if we just group based off of the individual ID, that's not necessarily going to provide us extra covariance that we would find useful for later data sorting. And so that's where it's important to think about your unique context. And the group here, we're including the dose in there, and that's important. Maybe if we wanted to, we could include weight BL if we really wanted to do some extra kind of context and analyses, some plots based off of weight. Having that in the group is going to, while it's also going to stratify your NCA analysis. So you don't want to use that necessarily if you don't have to. It will carry those covariates forward into your population and your readouts. So if we run this population, oops, scroll all the way back down, it was successful, able to make our population, and again, spot check it. We have 60 subjects, and there are 6 different doses, 0 missing, 0 BOQ. Awesome. With this, we can also then use some of our helper functions to be able to help plot and understand our data further. We can run observations versus time to be able to individually generate plots for our subjects. And there really, this is just focusing on a little bit more of just plot dynamics and kind of what you call it, customizations. But really what I want you to take out of this is, with this, helper function, and when it's set up properly, calling our NCA population, we're able to get it to automatically generate, 60 individual subject concentration time profiles for us. And we'll get them to call that later here in our NCA or our QMD, file. We'll run a second version of this with the log version. So Y scale is log 10. Always important to be able to look at that for estimation of the elimination rate. And this, I just want you to understand, when you see panel tab set, this is something unique for QMD files. It'll make more sense when we look at the HTML file, but it creates a panel and, with individual tabs labeled, tab 1, tab 2, tab 3. And we are pulling from that observation time log. So this observation time log scaled version, we're having to pull the first item from that vector. So that vector is 60 elements long for each of our 60 individual subjects. So we could, in theory, go out to tab 60. We could paginate this to be able to include something like 9 individual subjects per each tab, limit the number of individual vectors. That's, a customization that you can do just for the purposes of kind of, we're just showing the first 7 just as an example. We can also run a summary observation versus time plot. Again, using handy helper functions, summary observation versus time, being able to give us a breakdown, look at the mean and develop our mean concentration time profiles. And again, everybody has their own sort of setup. This is just all in black, depending if you are in a black and white setup, that's great. I got to admit, I like color. We know that we have 6 different dose groups. So, you can make blue, red, green, orange, and purple, if I can spell. Run this again, and it makes it, colorful. We can, get it to add a figure legend. If we have it remove the separation, whoops. Separate equals true. Let's see if it'll. I'm doing something wrong. It was working before. Being able to get things to show, several of these different kind of on-off switches that we have for keyword arguments, or maybe be able to show individual subjects, so you can make kind of our typical spaghetti plot, where this represents the mean line. You can show individual gray lines for each of the individual subjects that it's kind of revolving around. Separation involves, this is all of our plots being able to put onto one plot. We can have it where it's actually 6 individual plots, so it's just the mean concentration time profile for an individual dose. Again, this is all based off of more of just what you're interested in seeing and how you digest your own information. Third and final, so we data wrangled, step 1. Step 2, created the NCA population using read NCA. Now we actually generate the actual NCA PK parameters. Step 3, that's run NCA from our population object. And the important thing to know coming from there is we get this report DF as part of the object, which shows, all of our, or list, create the data frame of our individual PK parameters. Now, for some, that could be, sufficient enough. But of course, there are certain kind of diagnostics that we would want to run, individual subject fits, to be able to double check to make sure, well, was it generating, or what was it basing the elimination, and half-life off of? And is it appropriate? What is that adjusted R-squared value? So you can generate each of that of those plots and summarize it. We we report our observations in nanograms per ml, and so we do kind of our own little unit conversion here, converting, for this case, volume and clearance instead of milliliters up to liters. And so, again, using table 1 then to take our NCA report data frame, change the individual title headers into something that's a little bit more, nice and presentation worthy, and to be able to generate our summary statistics separated based off of dose, and again, our typical kind of setup, as well as then we can use, again, our listing table combined with a summary, so we can also just subset the number, maybe we're only interested in these 5 parameters. And admittedly, these are probably the top 5 parameters that we would be most interested in looking at within a SAD report. So we can just create a vector of those particular PK parameters of interest, and essentially just create a subset data frame summarizing just those 5. And actually, I can't remember who asked the question. Something to be able to look into within the Julian language. There's something called a dictionary. This might be a good option in terms of using this as a quote-unquote code book. If you want to be able to have a listing or, a running kind of object to be able to convert those headers into more uniform, more descriptive sort of titles. Getting into those sort of specifics is going to be beyond kind of the scope of this workshop. But just knowing, that name. So again, focusing on knowing what a dictionary is within the Julia language might be something of interest for you to be able to look at. And we'll generate just a listing table, from there. Again, just, using that same data frame, generalized table one sort of dynamics of sorting off a dose and ID. And I just want to introduce you to the fact because of you can modify your data, because trying to scroll through this can be cumbersome. It's a really long table, right? However, sorry, and I clicked off on the side here, and so I jumped. You can set up items so it performs functions in a loop. What I really want you to kind of just understand, you may not understand, the code on how to do this, because really this listing code is the same as what generated this above. We are now asking it that for each unique dose within this data frame, which we're just going to call D, if you look at that dose within the data frame and it's equal, it's going to create a different subset. So it's going to generate automatically for 6 different subsets based off of that dose information: 1, 3, 10, 30, 100, and 300 milligrams. And then it generates that listing table for us. So instead of one giant long table, now it generates smaller, easier to handle kind of bite-sized chunks. So just know, once you get used to the language, there are ways for you to be able to kind of help operationalize and really improve kind of your output just by using, don't waste your efforts of just copy, paste, repeat, copy, paste, repeat. Let's stick it into a loop. The idea of mapping functions is going to be very utilitarian for you in the future. And then finally, we could make a couple, plots. Again, I'm just going to kind of lay these out here. We're going to talk about visualizations later on with our PK, or within our pop PK sort of section. But we'll lay out, some box plots for Cmax. We can also use some of our other, violin plots and helper functions for things like Tmax or half-life, to be able to look at these, side by side and, look at the data. It's like, oh, well, clearly, the Tmax was a little bit more variable in the 30 and 100, milligrams cohorts comparative to, all of our others. Same idea, but it looks like, elimination half-life, was fairly similar across all of our dose cohorts, and maybe we're starting to see a little bit of a shift, at our 300 milligram, clearances. And then finally, dose proportionality assessment. So, a true statistical test. Typically, we're going to want to do this for AUC infinity and Cmax in most cases, and you're going to have AUC last, in a lot of cases as well, or AUC tau. For examples here, we have AUC infinity and Cmax again, which makes more sense for the single ascending dose design. That comes in kind of 3 individual helper functions versus the actual power model, where it reads in and it uses that NCA report to be able to pull in all the data and everything that you've organized already. You tell it what it is, the term that you want it to run the power model off of, and the confidence level. And that's going to give you then your dose linearity, power model estimates. So that estimate for beta. Similarly, you can then also run the ratio test to be able to, let it see, and also the 95% confidence intervals, around, what we expect, that jump from the lowest dose of 1 milligram to 3, we expect a ratio of 3, based off of the PK parameters as estimating it, it's a kind of an estimate of 2.3 with a high of 159 and 3.33. And then, of course, kind of usually what we like to see is the actual graphed out version of this. Blow this up for everybody. So this, we're able to see, the individual, PK parameters. So again, we're focusing here on AUC infinity at each of our individual dose levels, and it's showing us the power model with its 95% confidence interval, highlighted in gray, along with this kind of dot and dash line for the geometric mean. So it lets us be able to assess and, visually look at, do we see, are we following in a relatively dose linear, dose proportional assessment? We actually already, can tell from the model fitting the fact that, our estimate is below 1, that it is, increasing in a slightly less than dose proportional manner. And, our beta coefficient actually doesn't contain 1 at all. So at least up to the dose of 300, we would probably say, it's not increasing in a dose proportional, sort of manner. So, we run this again for Cmax, again, just for the sake of time. I want to jump and just show you, again, we did all this in a QMD file for a reason. And that is because when we render this then into an HTML, it creates a very nice, organized, pretty report for you. So all of that, extra talk about the aims, the objectives, your study handling design, all that typed out data is presented in a nice, uniform, clean fashion. All of the kind of those code blocks are missing, though you can look at them if you want to. But it gives you a nice, crisp, clean, layouts of all of your tables. So to be able to review your data, let's say you only had the first, 3 cohorts, you only had 1, 3, and 10 done. Great. You only have the 3, but now I need to update with the 30 milligram data. Really, you're using the same exact code base, and you're going to be able to just update it with your 30 milligram tab and generate a nice, crisp, clean report and summary within minutes, not within hours. This is that panel tab set sort of idea. So you're able to create, flick through tabs, and, we're just looking at the first 7 subjects. I didn't re-render, so this is that black and white version of the mean summary time plot. Again, we're only looking at the first 5 rows of our NCA parameter subset, but we generated, a quick check to be able to check our diagnostics for the half-life and elimination. We have our summary statistics of our PK parameters of interest. We have an actual listing of our PK parameters with summary statistics. And actually, I removed the one. I didn't remove the one. This is our individual one. So they have individual footnotes hidden on the bottom there. Again, looking at some of our just basic Tmax plots, clearance, volume, and distribution, and our dose proportionality assessment with an interpretation contained kind of within that panel tab set, which we already talked about here. So since the slope is a little bit less than 1, the AUC is increasing slightly less than a dose rate. So, depending on what your individual program, drug development program sort of contexts are, this makes a nice internal sort of, reporting tool to be able to look at, NCA analyses, whether for a SAD/MAD study, for any sort of, PK, phase 1 style study, or also even going, within the preclinical, sort of realm. So I appreciate you, hanging on with me for today. I want to just, for any Q&A that you may find difficult to type out into a chat box. I saw there were a handful. I think Divya and Olivia were in the general voice chat within the Discord channel. I will jump in there right afterwards here too. So if you want to talk things out, I'll stick around and see who's around for questions as well that way.
If there is there are no questions, even I'm on the Discord channel, so if there's anything, just post a question there. But otherwise, have a good rest of the day, and I'll see you tomorrow, and we can kickstart our basics early in the morning, or actually noon. Sorry. Thank you.